We're going to go ahead and take a look at number 23 from section 3.7, inverse functions. 23 provides two functions. The first one is going to be f of x is equal to x plus 1 all over x. And the second function that they provide you is g of x is equal to 1 over x minus 1. And the goal of this problem, they want you to see if these two functions are actually inverses of each other. So in order to do that, we need to do composition of functions. And it's a little bit lengthy because what you're going to have to do is you're going to have to compose f of g of x, and then you're also going to want to compose g of f of x. Okay, and the results from both will actually give you your one conclusion that you can make. So for the first one, if we have f of g of x, then what we're saying is everywhere that we see an x, we're going to replace it with a g of x. So I'm going to just leave parentheses open, and I'm going to go through and switch out or swap out all the x's that I have for g of x's. Now I already know what g of x is going to be equal to. So in other words, I'm going to rewrite this so that this is 1 over x minus 1 plus 1 all over 1 over x minus 1. So this one is a little bit cumbersome because what you're dealing with is a complex fraction. In other words, you have a fraction within a fraction kind of thing. It's like the inceptions of rational representations. So what you're going to have to do here is, first off, I would rewrite this 1 as a fraction. So you would just leave that as a 1 over 1. And then give it a common denominator. So in this case, your common denominator in this first portion is going to be x minus 1. So go ahead and multiply the top and the bottom by an x minus 1. And at this point, I'm just going to go ahead and write everything in purple so that we keep switching back and forth the ink color. So this is going to become 1 plus x minus 1 all over x minus 1. And that's going to be all over 1 over x minus 1. I know that sounded kind of like a mouthful and maybe everything kind of blended together, just a bunch of x's, minuses, and 1's. So definitely feel free to rewind and rewatch a certain section of the video. But again, just to kind of explain it again, I have a 1 over a 1 here, and I want to give it that common denominator of x minus 1. So in order to do that, I have to multiply the numerator and the denominator portion of the fraction by an x minus 1 in order to use that common denominator. At this point, what you can do, since you've merged everything, I'm going to rewrite this as a division problem. So this becomes 1 plus x minus 1 all over x minus 1 divided by, so essentially what I'm doing here is I'm taking this division bar and I'm rewriting it as the operation sign, 1 over x minus 1. But note here that I can actually kind of clean this up. I have a positive 1 here and a negative 1. So my next line will read x over x minus 1. So I'm going to skip this representation. I'm going to flip the other one over, and I'm going to do this, make this a multiplication. These two values will cross cancel, and this will leave us with x over 1 or just x. And if you recall from class, this is actually what we want to see when we start composing two functions that are inverses of each other. So this only half proves that f of x and g of x are potentially inverse functions of each other. In order to guarantee that we did this correctly, we need to form the same composition, only this time g of f of x, as I have noted on the right side here. So to begin, everywhere that I see an x, I'm going to replace it with an f of x. So everywhere that I see an x, I'm going to put an f of x. And I know how to rewrite this. This is going to become 1 over. F of x is going to be x plus 1 over x. And this is going to be subtracted from 1. And again, we're going to repeat the same steps here. So first off, I'm going to go ahead and rewrite this 1 so that it is a 1 over a 1. And then I need to give it that common denominator. So what I'm going to do is I'm going to multiply both the top and the bottom by an x, because that is the common denominator that I'm seeing between x and 1. So again, at this point I'm going to go ahead and switch to a common ink. So I have 1 over x plus 1 minus x all over x, if you were to clean up this portion that I have circled right here. Again, if you need to, please make sure that you pause and stop the video and work this out to make sure that you agree with me. Okay, so if we notice here, these x's will cancel each other out. They're additive inverses of one another. So this is going to leave me with 1 over x. In other words, I can rewrite this as 1, and again, this bar can act as the division bar. So 1 divided by 1 over x. And then we can use what we know about dividing with fractions. I'm going to skip the first representation, I'm going to flip the other one over, and I'm going to make this multiplication. Well, 1 times x over 1 is just x. So if you notice, the two values that we have after composing both of the functions is just x. In other words, this is the identity function. Recall that the identity function is y is equal to x. The fact that when we compose both of these functions and the result has been x in both instances, this verifies that these functions are inverses of each other. So really what we could do here in this case maybe would be to change the notation to actually communicate that. Instead of g of x, we could say f inverse of x to guarantee that if individuals were looking at both of these functions, they would know that one is the inverse of the other. I hope that that helped. If you have any questions, please feel free to come see me.